let me just move forward a little bit and then get back. So the meaning of surface of force mining constraints. Okay, I have my topography region or surface in yellow. I have my surface constraint in blue, which is, in this case, it's the force mining. So it means actually the minimum depth I should achieve. So starting from the topography, I will achieve at least this depth in all these points over here. Okay, so I will achieve at least these depth represented in red. Okay, so force mining for any means is understood as the minimum depth the algorithm should achieve in a specified paired range. Okay, the same paired range over here. Okay. Okay, so moving to the restricted mining, we have a different understanding over here. We have the same topography. Let's say we have the same surface constraint, or it could be anything, but it means that, for example, I cannot surpass this limit. Okay, so the restricted mining surface, which is represented in blue, is the maximum depth I should achieve. So I cannot surpass this depth for any reasons. Okay, so getting back to force mining, for example, we have this sort of possible situation. Let's say I have a moot mine deposit. Okay, so sorry for my drawings over here. Let's say I have a moot mine deposit. We have a small pit, big pit. Okay. And let's assume that I want to test, what if I deplete, or maybe I'm seeing already a tendency or trend of this material being mined in the first years, and I want to force it more so I could deplete all these small pits prior to moving to the big one. Okay, that could be a possibility. So in this regard, what could be done would be the following. Okay, I could take my pit over here and I could establish a surface constraint or a force mining in which I would force this region over here. Okay, I could force something like this. Okay, so I could force this pit to be mined within for example, period 1 to 5. Let's say that in the previous case, in the base case, it was taking maybe 4 years to mine 80% of it, and then the rest was mined in 10 years. So what I can do to force is to create a surface constraint based on this pit and force it to from 1 to 5, for example. Okay, so this is the idea of forcing mining. I could use this strategy to backfill this pit with waste material. I could use this strategy, for example, to allocate an in-pit crusher inside my pit. And there are also more and more possibilities on these. Okay, so having this understand, I could use then the surface up to period 5, let's say. Okay, I want to force that surface up to period 5. Okay, but if I'm forcing it from 2 to 5, I'm also necessarily I'm also forcing the same surface from 1 to 1, because if I'm forcing up to period 5, I'm forcing it in all the previous periods. Okay, so you don't need to replicate the same surface over here, surface, and also, let's say, here. Okay, you don't need to put the surface in all these fields. You just need the surface in here. Okay, so this is maybe something that will facilitate for you. Another point about this is the fact that for each paired range, we have the possibility of using just one file. Okay, this means that, for example, what if I need to force not only this area over here, but also this area over here? Okay, in this case, I should format the same grid of points. I mean, like this one, to force this region and this region over here. Okay, so that would be the way I would just project points along the z direction to go up or go down, or go down or go up. And I would project those regions, this one and this one, so they could be applied during the same, for example, the same paired range. Maybe I have a different situation. Maybe I have this bit over here would be forced from 1 to 5, and this one would be forced from just paired 1. So in this case, I would have this flexibility of setting up surface 1 over here, surface 1, and here I would have surface 2. Okay, so in this case, what I would be doing would be, for example, having these applied to a surface based on these, applied to paired 1 to 1, and these other surface would be applied to 2 to 5. Okay, I would be also probably forcing, maybe, I believe it's not needed, but I could also force these region from 2 to 5 just in case. In any case, this would be the formatting for this last example. Another point, so the ultimate information you need here is that when you force a surface for a given paired range, you are necessarily forcing it to all the previous pairs, even if you have previous pairs that are not in this range. So all you need to take into account is the final pair. Okay, so if I'm forcing these from 2 to 5, I'm necessarily forcing it from 1 to 1 as well. The same for restricted mining. For example, for restricted mining, I could have the following situation. I could have my pit. Let's say I have my pit over here. Okay, sorry for my drawings, my awful drawings, but let's say I don't have the mining rights. Okay, I don't have the mining rights from this area. So these are my mining rights. Okay, mining rights. I don't have these mining rights. So anything below the surface or this grid of the surface will not be mined. Okay, anything immediately below these, let's imagine a projection of this rectangle over here up to the base of the model. This region would not be mined until the specified period of time. So if, for example, I have a restricted mining surface, let's say it's a restricted mining, okay, I'm applying to the first year. Maybe I will have these mining rights in the second year, so I'm restricting it from 1 to 1. But maybe these mining rights will be available just in year 6. So I will use this surface over here. I don't need to use it from 1 to 1, because if I'm restricting all this region from 2 to 6, I also cannot enter it from 1 to 1. It's implication of applying it to this region. It's that all the previous ranges will be also restricted. Okay, so this is a natural implication. So whether we are using force mining or restricted mining, we'll consider especially the final period of the range specified. Okay, so this is the most important thing to take into account when we are considering paired range versus surface mine constraints. Okay. Okay, so taking these into account is the fact that we can take advantage of surface